Hi, this is the new dynamic theatre lighting rig that I've designed, and I'm really, really excited about this project. So what this solves is a problem in theatre, which is that these are moving lights, and these are kind of the peak of dynamism, right? They're really, really cool. They can move the light to the head of the lamp here, they can twist around, so they can pretty access any position kind of in this range over here. But what's kind of a drawback of these, and every light in the theatre, is that they can't change their actual position. They can't move up and down on this rail, side to side, and which is just really there's a few drawbacks. For instance, so number one, you can't do really, really interesting shadow effects, which could maybe happen if we had them moving up and down. And also, secondly, it's just more expensive, because if you want to have a light at this position and this position, you have to have two lights, which is really, really sad. Instead, we could solve this by just having one light that can move up and down. We could save money because lamps are expensive, and you just open up a whole new world of lighting design, which would be really, really cool. So I've created a solution which will allow a theatre light to move up and down and control its position and can stop at any single point here. And this could be done in between lighting cues to kind of readjust where the lamp goes. It could be done during a lighting cue to have some really, really interesting moving effects of lights, to make kind of really interesting shadows, and it could have so many possibilities. And so this is the prototype that I'm working on. I'm going to now demonstrate the system. I'm controlling it using the open source ODrive GUI and controlling the velocity of the motor. I'm going to move it one way, then the other way, and the other way, then the other way, and the other way. Whoa. Wee. 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 Super cool, right? So I've been quite involved in theatre for the last few years, and mostly in the tech side, and I'm really grateful for Paul McLeish, used to be the chief lighting designer at the National Theatre, and has mentored me and helped me a lot in tech and learning so much, and he's a brilliant, brilliant mentor. And he actually inspired me for this project, because he was talking about how he wished lights could change position on a beam, and I just thought to myself, gosh, this sounds really, really amazing, and I just designed it and got really, really into it. And so this is a prototype version of that, and hopefully we can bring it out to theatres across the UK and the world. So I'm now going to explain how this system really works. So the whole premise of the system is that we're going to be able to move this light from along this beam. So this beam is a unibeam sold by EEE Engineering. I borrowed this from the school. It's a very, very good theatre beam, and it's used for carrying kind of really heavy loads, such as this light here. So I'm also using these EEE bearing kind of rails here. This is usually used for tabs or curtains in the theatre, but I thought these could actually be really, really good because tabs are actually quite heavy, and so they're really, really good for carrying this sort of light. This light was also borrowed from school. Thank you very much to the drama department for allowing me to take it home with me. So I'm controlling this position using this motor here, and this motor is sitting on this 3D printed mount. This blue mount, which I designed myself, and this is slotting into these the bearings of the curtain holders here. And what happens is that this motor has a timing belt pulley on the shaft, and the timing belt is held taut by these two G clamps on the either end here. And the timing belt, as the timing belt turns, it will move up and down along this rail. The timing belt pulley turns, move up and down this rail. I've got these two sets of wheel bearings here, which are just some machine screws with some nuts in between, and these help the whole system kind of slide smoothly on top of this beam. This is actually really interesting because it's very difficult to find one single size wheel bearing that will fit along this kind of 20mm gap. So I actually put two of these small wheel bearings together to make one kind of larger one. And I'm using a 270 kilovolt ODrive motor alongside with a encoder to kind of create a sort of a brushless servo motor. This is sitting inside this 3D printed mount here. This blank mount is designed by ODrive themselves, and so I took it and I'm crediting them alongside this cover plate here. So this is controlled by a 3-phase motor controller. This is for the ODrive S1 board, which is really, really kind of nice, small motor controller driver board. And this all has a brake resistor connected to it, and it's powered by a 12 volt power supply with 12 volt 1 amp power supply. 1 amp is really not enough for a kind of high power situations, but for now it's the best I have, so I'm going to be probably hoping to get a bigger power supply. This is controlled by USB signals, which is running through to my computer here, which I'm controlling the motor using the ODrive open source GUI. And that's sort of how it works. So whilst designing this system, I went through a number of iterations of this 3D printed mount. So this is the first iteration here. You can see it's kind of very basic. My plan was to have this just holding the button and then the motor going somewhere else, but this never actually worked out. Here, the full kind of most similar to what we have today kind of design revision. You can see here these bits broke off the top during a filament change. And there were some problems with it, such as the strength of these cylinders at the top. The motor wasn't really fitting nicely into here, and also the wheel was actually level with the base of this, which really meant that actually what was happening was that this base actually was sliding along the rail, which is really not what I wanted, and it wasn't really moving very smoothly. And we go on to this side. What I've done is I've moved the holes down a bit, so the wheel is actually sitting about 3 millimeters below this level. I've also increased the strength of this with kind of a fillet. However, some problems still exist, which is that I wanted to be a bit lower. I think this is a bit too thick, so it can kind of ride off a bit. I wanted to reduce this by about 10 millimeters because it was actually riding a bit too high, and the wheels were kind of floating. And this kind of new mounting system I developed wasn't really working, so I kind of reduced the height of this a bit for the next design. And that was the design revisions. And the problems that I faced when doing this, initially this actually only moved one way. But what was happening is this timing belt wasn't tight enough. So I just had to tighten it on either end a bit more. And then it could move really nicely both ways. And that was really, really great. That's it. In the future, to expand out, my plan is to get encoding into this. So my plan is to, in order to eliminate limit switches, instead I'm going to program a homing sequence, calibration sequence, which will kind of travel this way and that way. And when the ODrive detects too much power being drawn as it tries to push against the end, you'll know that it's hit the end. And we can then determine that's the encoder position, final encoder position, and be the same on this way, unless you can program any position in between. I'm also planning to bring this into the theater and kind of get it rigged up fully. I also want to change the mounting point of this light here to kind of get it distributed evenly amongst these two pulleys so that the weight can be really evenly distributed and this kind of swings less. I want to have a longer beam so it has more kind of expansion then. And then I think what I really want to do is actually kind of bring this to kind of a two-dimensional pinion system. So we have the motor moving both this way and moving that way on two different rails. I mean, how cool would that be, right? And that's sort of what I want to do for the future. And thank you for watching.